Hello, this is O. Morgan from omorganlabs.com, and today we're going to talk about probability, independent and dependent events. Okay, say you have a jar of marbles. This is our jar of marbles, okay? And we have 4 red marbles, and then we have 2 blue marbles. Usually, when we talk about independent and dependent events and probability, the question comes up, what's the probability of drawing a red marble and then drawing a blue marble or something like that? Okay, but first we have to define independent and dependent events. Okay, so on the first draw, if we take out a marble, replace it. On draw 2, we take out a marble. Okay, replace it. Those are termed independent events because each draw it resets. Okay, you have 1, 2, 3, 4, 5. You have 6 marbles in total. So there's 6 different outcomes that can happen when you're choosing marbles. Okay? Independent events. Draw 1, you take 1 out and put it back. Draw 2, you take 1 out, put it back. Okay? Independent events. Simple. Now, okay, so let's go into dependent events. Okay, you probably can guess. Draw 1, you take out a marble, you leave it out there. Draw 2, you take out another marble, leave it out there. In this scenario, your total possible number of outcomes changes, right? You draw 1, it goes from 6 down to 5, okay? Your total number of possible outcomes. This is important when you're setting up your fraction because probabilities, you can think of them as fractions. So let's go into the problem. What's the probability that on the first draw, you'll draw a red marble, and on the second draw, you draw a blue marble? Let's do the first case of an independent event. The event is independent. Okay, let me move this over. Okay, so the first draw is independent. So how many red marbles do we have? We have 4 red marbles, right? 1, 2, 3, 4. 4 red marbles. What's the total number of marbles? 6. So the total number of outcomes is 6. But the number of specific outcomes is 4, okay? Because we have 4 red marbles. That's the first equation or fraction. When you have events, you always multiply the probabilities together, okay? You always multiply, okay? So once you figure out how to get the probability, you multiply it together. Okay, the second draw, draw 2. We replace it, so we still have 6 total outcomes, right? We still have 6 marbles because we replaced it. It's an independent event. I'm just repeating so you'll get it. How many blue marbles do we have? 1, 2. We have 2 blue marbles. So the fraction is 2 over 6. And if we multiply this out, we get 8 over 36. Okay, my handwriting's not that good. Let me try that again. 8 over 36. If you plug that into your calculator, you get something like 0.22. That's a decimal. We want to change it into a percent. So decimal to percent, you move the decimal place 2 points. So the probability of drawing a red marble and then drawing a blue marble is 22%, okay? The way I think of it is the weatherman. He'll say it's a 22% chance of rain. Do you get a jacket? Do you get a raincoat? Maybe. You may get a raincoat and you may put it in your car or something. It's probably not going to rain, okay? Probabilities are low. They won't happen, but maybe, you know, it's a 22% chance. It may happen, but it's not likely, right? And that's how you start talking when you talk about probabilities. You can't say it's not going to happen. You just say it's a low probability probably won't happen. Okay, now let's go into the dependent event question. Okay, so now this is dependent. Okay, dependent. If I can write here. Okay, it's not very good. Dependent event. We're going to draw one, leave it out there, right? And draw two, leave it out there. Okay. The second draw, your number of total outcomes goes down to 5. Okay. So the first probability is the same, 4 red marbles out of 6. But the second probability, you have 2 marbles out of 5, right? Because since it's a dependent event, right, this number, the number of possible outcomes, changes on the second fraction. So you multiply those two fractions, and you get something like 8 over 30. You divide that out in your calculator, you get 0.266. Change the decimal into a percent, it's 26%. So there's a 26% chance if you don't replace after your first draw that you'll draw a red and you'll draw a blue. So if you're at the casino and a guy says, hey, do you want to draw one, replace it, and then draw another? Or do you want to draw one, leave it out there, and then draw the second one? You better do the second case, right? You better use the dependent scenario, right? But anyway, kind of makes sense, right? Your probability increases if you reduce the number of possible outcomes, okay? 26% chance. But overall, the number's low, so you better not be a betting man with this. You know, if it's 26% chance, I'd keep my money in my pocket, okay? Low probabilities, probably won't happen. Don't stake your life on it. The high probabilities, you may want to spend a little money on it, right? Okay, 100% chance of rain, you better get your raincoat. It's going to rain, right? 2% chance it's going to rain. You put your raincoat in your car or in your closet. Okay, omorganlabs.com. Hope you learned something about probability. Enjoy and subscribe.